Oh, wow.
Like, seriously, like, look at this. You see that grossness? Like, horrible. Yeah. Keeping it real, people. This is how I look when I do my hair when it's wet yesterday and sleep in it and then pull it out this morning. Awesome.
Okay.
That's like me usually.
Oh, the joys. Can't wait till summer.
When do your kids get out of school?
The 21st.
Oh.
Yeah. When do your kids get out?
29th.
Oh, okay.
Yeah.
Oh, I wish I got out on the 29th of May. I never get out on the 29th of May. I've never gotten out on the 29th of May.
I know.
Yeah, my kids, like Emma, will be at girls' camp that whole week, that 26th through the 29th. And then Caleb will be at Havasupai Falls the 27th through the 30th.
Oh.
Yeah, so we get out early and they start them real fast.
Right away.
Yeah.
Yeah. Wow.
So, okay. All right, let me, I got to move you guys. Hold on. There we go.
Okay, so I feel like I got a pretty good grasp on all of this, but I am a little bit confused on how one would know if the graph was normally distributed.
You mean on 7C? Or let's see. No, which number? Because I was confused on 8.
On 8.
I got 8. Okay, so I think, Abby, what I understood, whenever it tells you, let me see where that sample is. Whenever it tells you a normally distributed mean, it will always be a normal bell-shaped.
Okay.
Because it'll tell you in there, like, it's normally distributed, and so, because it says the scores on the GMAT are normally distributed with a mean. And so, because it says it's normally distributed, it will always have that normal bell-shaped graph.
Mm-hmm.
Okay, so that's how
I understood it, but I'm not sure if that is 100% correct.
And so on the B part then, how did you know? It's because it told you the parent population is evenly distributed.
Yeah.
Okay. Because I looked at the answer key and obviously that's what it said, but I was like still confused, like if I was to do this on my homework assignment, like how did I know that? Okay. Speaking of homework, I failed the numbers.
No.
Did you guys do
Yes!
good?
Oh my gosh, I did too! And I felt so good about it. And I went back and I checked everything and I was like, I feel like I'm going crazy.
I did too. Like, I felt really good about it. Like, I felt like I knew it. So I don't know if my calculator, I just didn't punch it in wrong. If I punched it in right, I mean. But I was like, I do not understand.
Yeah.
I got a C, and I got a 70, and I, like, thought, and I went back and I realized I didn't do the homework prior to opening that quiz. You know how it had, like, the next chapter homework?
Uh-huh.
I totally did not do that. I totally forgot about it, and then I was like, I started doing this, and then I'm like, wait, none of that sounds familiar, and then I realized I didn't do the homework assignment. So I was like, oh. So I felt good on, like, most of it, but when I got a 70, I realized why, because I didn't do the homework and prepare myself for it, but I couldn't see, like, it doesn't pop up what I got wrong. Like, it doesn't show me, so I'm waiting for her to grade it.
And I emailed her because I was like, I don't understand. Like, I felt really good about it. Like, and then I got a 60%, and I was like, what in the world did I do? So
yeah, and that's the problem. You can't go back and check it. because it's
I think she
close.
does that so like you can't help other people.
How did you do, Catherine? You probably did good,
I'm
huh?
good on both.
You did.
You stink.
I did good on lesson 5, or 5, the first one.
Yeah.
Yeah. Okay, I have a question from this thing too. Hold on, let me see. Okay, so on part 2, number 7, part C.
Okay.
I do not like. Are they talking about when we talked about unusual and usual, like in the beginning of the lesson or the beginning of the school year, semester, whatever this is? Is that what they're talking about when it's asking if it's unusual or usual?
Well, at the beginning of this lesson, it was saying how if it's usual, if the mean is, okay, let me think about this. What? I don't know. Anybody else?
I think it's the exact same thing because it talks about usual and unusual, I think, in the lesson as well. But I mean, I think the usual is just the normal bell curve, and then unusual would be that anything that's not that.
Mm-hmm.
That's what I got from it. I don't know if that's correct.
Okay, because that's what I was thinking, but I didn't know if that was right because they didn't have the answer in there, and I'm like, okay, that's what I was thinking. Okay, so we do have to go over, what is it? D, right? Compare your mean with 3 other. Okay, so I got a mean of $47,480, which I think is right in the center. Like, well, close to it, but.
Yeah, and I got a mean of 46,240.
Okay, so hold on. Let me write down your guys' little things real quick. Okay, so Catherine, you got what?
I got a mean of 45,320.
320. Okay. And Tiffany, you got what?
I got a mean of 46,240.
240. And Abigail?
So I thought it was part of the instructions, and I kind of just went over it. So I am going to kind of doing that right now. Hold on. Okay, so let's see.
And then what did you get, Holly?
Oh, I got 47,480.
Okay. So possible combinations, 30 salaries, so that would be. Wait, is it the mean? Okay.
We're doing 7D.
Okay. Sorry. Can go on without me. Sorry.
You
I'm
see
sorry.
there, Abigail?
I'm sorry, say that one more time?
You see the numbers that are like right above part 2?
Oh, yes. Okay.
Just take 5 of those and get the mean of it.
Really?
Yeah, that's all.
Okay.
Wow.
Sweet. That's it? That's a lot of numbers.
Just take 5 of them.
Okay. For some reason, I thought down here when it asked about the mean. Oh, okay. I'm so sorry, guys. I'm dyslexic. I need to have people read to me. I was like, isn't it 30? I'm sorry, guys. I'm letting you down.
No, you're
Sorry.
I just know, like for me, from the two that we grabbed, I think they're all about in the middle.
Well, yeah, and it says, what did you get from it? Like, obviously, all of our means are different because we only took some of them.
Right.
Mm-hmm.
But they all seem to be
like it says, you only get this to see the means from the samples you draw. But they all tend to be, you know, close to
the center.
Yeah.
Okay, this makes a lot more sense. Sorry, I totally thought that mean was 30, and then you guys were like, yeah, 42,000 something something. I was like, that is a different number. And the reason why is because it's salaries and not mean. So sorry. So so the number I got was 42,760 for the mean.
Okay. So does everybody understand how to do number 8? Like how to get the sampling distribution?
Yeah.
Let me look here. 8. Oh, like the 8D.
Yeah.
Yeah.
Okay.
Yeah, I got that.
Okay,
Wait.
so do we
want to try the quiz?
Yes, I'm ready.
Yeah.
Okay.
Now I'm going to move you guys to over here and pull up the quiz. Okay. Start. Yes. True. True. First two are easy. Okay. Catherine, do you want to start us off? Miss 100% on her quiz.
I
know. Way to go! Seriously.
When taking samples of n, when n is equal to 5, what was the shape of the distribution of means histogram when the parent population is right skewed?
I think it was right skewed still.
Yeah, because it's not until you get into the bigger.
Yeah, because it's pulling it from the big part, and then it got smaller, and so it was right. You know, so it was like curved like that.
Yeah.
Yeah, that's what I would think too.
Okay. Tiffany, go ahead.
When taking samples of n equals 100, what was the shape of the distribution of means histogram when the parent population is right screwed?
I still think it was right.
Is it, because I can't remember when it started, because it eventually starts to get just normal, doesn't it?
Can we pull it up and do it?
What is that, bigger numbers?
Yeah, let me read my sheet real quick. Hold on.
Isn't that law of large numbers?
That's what I'm thinking. Like, if the sample size is over 30, it is traditionally thought to be sufficiently large so that our mean will be normal.
Okay. Okay, parent population heavily skewed. N equals 30 or more. Then yeah, it'll be normally distributed.
I think when it's, because there was that one rule that said if the parent population is not normal, which this is what that is, right?
Yeah.
The central limit theorem guarantees that the distribution of the sample mean will be approximately normal if the sample size n is large.
Yeah, I think once it starts getting over 30 is when it starts to go back to normal.
Yeah.
You guys are right. Yep, you're 100% right.
Normal.
Okay, normal. Yeah, and it's only, okay, so yeah, the parent population, if the parent population is normal and n equals 5, then it will be a normal distribution. Mm-hmm. But if it's skewed, then it's going to stay skewed if it's small, right?
Yeah.
Yeah.
Okay. Got it.
So then on 5, it should just be normal.
Yeah, it should be normal 5. Because if it's normal distributed, then it's going to be normal.
It's going to be normal anyway. Yeah. Okay, number 6. When would the distribution of means be normally distributed? Choose all correct responses. Okay, so let me get my notes out.
Distribution means
Data are drawn for population that is normally distributed and sample size is small. That's true, right?
Yeah.
yes.
Okay, drawn from a population that is normally distributed and the sample size is large. That's right, right?
Right.
Yeah.
Drawn, the population is right skewed and the sample size is small. No.
No.
And then population is right skewed, but the sample size is large. Yes.
Right.
Yeah.
Mm-hmm.
Got it. Okay, Abby, your turn.
All right. Which of the following gives the best explanation of the central limit theorem? If the parent population sorry, it's pretty bad today. From which the data, gosh, okay, I'm starting over. A, if the parent population from which the data are drawn is normally distributed, then the sample means will follow the normal distribution. For bell-shaped data, approximately 68% of the data will be within one standard deviation of the mean. About 95% of the data will be within 2 standard deviations of the mean, and approximately 99.7%. Sorry.
Bless you.
Thank you. 99.7% of the data will be within 3 standard deviations of the mean. If the sample size is large, the sample mean x will be close to the population mean. If the sample size is large, the shape of the sample distribution, the sample mean will be approximately normal.
I think it's the last one.
That's what I think too.
Because that's what I wrote down.
Okay, so you want me to read again? Practice makes perfect. Let x be a random variable with the population mean and the population standard deviation. Oh, and then the mean is 10, and then the standard deviation is 6. Suppose a sample of size n equals 36 is drawn from the population. What does the mean distribution of the sample? It's the mean equals 10, standard deviation 6, so 6 over square root of 36. Yeah, shoot. Wait, so, oh yeah, duh. I got one.
That's what I got.
You got one?
Yep.
Yeah.
Yep, that's what I got.
Okay.
Okay, what is the standard deviation of the distribution of sample means? 3 decimal places.
Okay, hold on. I have to go back to my standard deviation thing.
Have fun.
Is it just 6?
Hold on. I have to go back to whatever lesson this is. Hold on.
What is the standard deviation?
Wouldn't it just be 6?
Yeah, that's what I'm
That's
thinking.
what I think.
10.
I'll take one for the team today, just in case.
Squared. Yeah, I think it's 6.
Yeah, I'm pretty sure.
Because you just,
Well, it's right there in the question.
Well, because it would be, I mean, of the
Yeah.
sample means, but because
it throws
the
you off.
sample mean is going to be close to the population mean.
Right.
So, yeah.
Hold on, wait. Okay, that's population. Okay, hold on. Okay, so mean was, hold up. Sorry, I'm like, my brain's working a little bit different today, I guess. Okay, so my mean is 10. Sample variance. 36.
I'm kind of wondering if it's 1, 2, because, well,
I don't think it's 1. I think
sorry, I think it's 6 now. Just reading again. I saw.
I told you, but I don't know. That whole 3 decimals is throwing me off.
Yeah, I think they just do that.
To throw you off.
Yeah.
Yeah.
Okay.
Yeah, I would say it's
Before where I never used it, and they just put it in there.
Okay.
I'm pretty sure in the reading it said that.
Yeah, that's what. Well, hold on.
Well, didn't it on the practice, the preparation one, wasn't there one like that too? It asked for the standard deviation and it was just right there.
Hold on, I'm looking.
Yeah.
I'm gonna pull up my thing again.
Yeah, it's on C. It's like, what is the mean of the sampling distribution of the sample mean scores for all such samples?
So
And
wait,
it was 521.9.
but it's
like-
asking for standard deviation, right?
Yeah.
That's a D on number 8. The standard deviation is that little O symbol divided by the square root of n.
So then would the mean of the deviation be 10 on number 8?
It would be 6 divided by the square root of 36.
Which is 1.
Which is 1, which is what we did on 8.
Yeah.
Oh, what is the...
Did we do
Oh,
it?
you know what? So what is the 8 should be 10 and 9 should be 1.
Yeah, 8.
Right?
Yeah.
Yeah, 8 was wrong and 9 is.
And then 9 is the 1.
Yeah,
Okay.
there we go.
Right?
Yeah.
Yes. Okay. So 8 is 10. Oh my heck! I knew something wasn't sounding right. Okay.
Deviation of
What is
standard.
the distribution example means? Population. Yeah.
Okay.
All right.
Yeah,
So-
because C would be R8.
What?
As what?
8C would be
Yeah.
number 8 that we're working on. And then 8D is number 9 that we're working on.
Yeah.
Got it. Okay. Wow. Thanks for using big words that confuse us.
So, well,
Okay.
10's easy.
Yeah.
Regardless of the distribution of the population, if the sample size is n or is less than 30, what would be the shape distribution of the distribution of the mean?
Normal.
Normal.
Yeah. Good. Because if it's greater than 30, then they said in this assignment it'd be normal.
And then what theorem would justify a response to question 10? Is that the law of large numbers?
Hold on. Let me look real quick. I wrote it down. Okay, large numbers. If the sample size is large, then the sample mean will typically be close to the population mean, U, or that little thing. Yes.
Yeah, law of large numbers.
Yeah.
Yeah.
What would be the central limit theorem?
The central limit one was,
Place the sample size is large, that X will be approximately normal. The law of
normally distributed.
states that the sample mean X will be close to U. So would it be the central limit theorem?
We answered this in number whatever it was.
I think, actually, I wonder if it's central limit theorem.
That's what I'm thinking. Central limit theorem just sounds more like it.
Because I think in the homework, I remember reading that. And I even wrote that under central limit theorem in my notes. If sample size is around 30, it is sufficiently thought to be sufficiently large. And I wrote that under the central limit theorem, but...
Yeah, because number 5, it's the central limit theorem states that if the sample size is large,
yes,
it will be approximately normally distributed.
Yeah, okay, so this is what I wrote. So number 5, it's the central limit theorem states that if a sample size is large, the sample mean will approximately be normally distributed. That is it. The law of large numbers states that as a sample size increases, the standard deviation, the sample mean, will get smaller.
Yeah, so it's the central limit theorem.
Yes.
Yeah.
Yeah.
All right, Abigail, you're up.
All right. It's going down. Yeah, it's going up. Oh, guys, 100%.
Sweet.
Great.
Yay! We win.
Yeah.
My stress levels went down.
Yay!
Now I just can't forget to do the homework before I take the quiz.
I still did it and didn't do good, so I don't know what I did last week.
I don't know.
I know. I am so mad. I went in there. I was like, I got this. I wrote this test. It was, oh my gosh. I'm so irritated.
I know.
That's okay. Things happen for a reason. I just wish it didn't have to happen that way. Oh. Oh well.
Okay.
All right. We'll see you guys on Thursday then.
All right. Yeah, for sure. You too.
Yep.
Okay. See you guys.
Bye.